Hi, in this segment we will finish the chapter on life annuities. So what we will look at, we will start by looking at life tables. We already use life tables in other sections, so by now they are familiar to you. And this is the life tables, one bit of it. So what we need to see here, that we can find life annuities. They are actually here, right? You see them? Let me use red color so you can see it. Right? This is the life annuities that we computed manually. And what you notice that this is life annuity due, which is at the beginning of the year. There are two dots on top of it, so it tells us at the beginning of the year. So for instance, if you want to find life annuity that issued for a person at age 40, so you go to age 40 here, and then you go here, right? You see where they meet. So it's 18, right? This one. So you can write A40 is 18.457. Right? So that's straightforward, right? There is nothing complicated about it. But what we can recognize that we can use it also to calculate other things that might have not checked it before. For instance, what if you are asked to calculate A40? And this is not at the beginning of the year. This is at the end of the year. We already looked at the relationship between them, because all you need to do is subtract one. Right? If you go back to what we discussed last session, so all you need to do is you take A40, subtract 1. So it will be, oh, sorry, here there is a, it will be now 17.4578, right? So you can play with it as much as you wanted. But it can get little bit also more complicated also. But you know, this is, we calculated A40. Before we get into more complicated cases, let's verify this one. Remember, this one can be written 1 minus A40 divided by D. Right. Let's verify it also with the, we got it this one. Let's verify it. It's 1 minus A40. You can go here and you go to the A and you go to the same 40, which is actually the next one. 12106. 12016. Did I get, yeah, right? And you need to divide it by I, which is here the life table provided by Society of Actuaries, it's at 5%. Right? We divide it by now 0.5 because it's D over 105. It should give you the same answer. If little bit of difference is because of rounding up, you know, because this is life table, is rounding it up. It's actually, you can download from the Society of Actuaries the Excel file that has the formula for this life table, so you can then get the accurate result. So what I got here is 18.47664. It's not much of different, right? It's not much of difference. It's the only little difference here is because of the rounding up. Right? It's because of it's actually, I need to verify it. It's maybe I made a mistake here. Oh, I made a mistake. This is bigger than what it should be. Yeah, when I copied the number here, I made a mistake. 2106, right? So let's do it again. I think I made a mistake. This little mistake will change the number. It shouldn't be the difference that significant. Now you compare this one with this one. It's the first 3 digits the same, and this one is rounded up, right? So it's very good. It's very good. It's because of rounding up. What if you are asked to calculate now A and 40, but the payment is made monthly, 1/mth, 1 over 112 every month. So we need to have here 412. Right, we already looked how we calculate this one. There, from the life table, you will not find this one. But there are two ways how we calculate this one. The one way is to recognize that this one is 1 minus A 12 and divided by D 12. Right, and this is something we already did before. So now we need to take A12 separately. What's A12? Under UDD. So this is approximation using the assumption of uniform distribution of death. Under UDD now you can calculate A12. Remember this one we did it before in the theory for how we calculate insurance benefit paid monthly. So this one will be I divided by I12. Right, we already computed this one, multiplied by A40. This one we computed last time, right? We computed last time, but I'll show you also another way to, also you can find this I over I12. We already computed in the last session, but let's write it quickly, the answer here, and then I'll show you a different way. This will be 102771. This one you go back and see how we calculated it. It's simple. Multiplied by the A40 now, we go to the A capital 40. Go to A40 is 12106. And this gives us, if you calculate this one, 0.123809. Now D12, we already calculated it last time. I don't want to calculate it again. It's just simply use the rule. This one when we calculated last time, 04869. Now this one become 1 minus 0.123809. This is from here, divided by 04869. Let's see, this one we got it here, and this one we got it here. So we can calculate lots of things here, and now if you do the math for this one, what you will get for this one is 179953. Right? It's simple, not much of a complication here, but let's calculate it alternatively. Because this one more or less we did all the pieces before. We did all the pieces before. The only thing we plug in the A40 from the table. Now the alternative way, the new way that I will look at now, is to calculate this one, and let's have the general form here. Let's do the general form for M. It can be 2, it can be 3, it can be every every quarter of the year, then M is 4. If every monthly, M is 12. Then if it's payments made half $1 every 6 months, then M is 2, whatever the value. And this is, remember that at the beginning of the period, there is annotation for this one is alpha M, then multiplied by the annual one, then you add to it, let me write the X correctly here, then you subtract from it beta M. And this is something we need to remember. This one you need to remember. You need to memorize this one. What is alpha? What's beta M? Let's look at that. Where we find them. There is a way to calculate them, but I don't want you to calculate them. I want you to show in the life table also. If you go back to the life table, let me download it again. And this is what you have from site of Actuaries. This page here, I'll upload it for you to see it. We looked at it last time, so we know what is being offered here. we know what's being here. You have actually I over IM or D over DM. It's already given here. So I over IM, remember when we, this I over I12, you can calculate it here, right? I over I12 is 10271, which is 102771. So it's there. But just also for you to know. But what is alpha and beta? You see them here, and this is the formula for them. We're not going to do the formula because they already computed for us for the interest available here. Unless I change the interest and I give you different, then you need to calculate them. But I usually with already given here with the interest. So let's look at it. Right. So how we calculate A? Now we need to calculate what we are looking at is calculating A12. How we can calculate A12 for somebody age 40, right? Because we're looking at age 40. We calculated it one way. Now the other way is to calculate it. Then we have alpha 12 A40 minus beta 12. So this can be straightforward, very easy. Look, let's look at alpha 12. Alpha 12 is here, right? This one. It's 1302. 1302. What is A40? Or we already found A40. You know, we don't know. I have the table here, so instead of keep going back and forth, I assume that all of you guys, you print the table, so you don't need to keep going back and forth in looking at the video. So you need to, when you do this, especially this session, you need to have the live table in, with you. So A40 is 0, 1. Not the, I mean, this is the annuity. Let's need 18.4578, right? And we need to subtract from it. Let's subtract from it the beta, and the beta 12 is 42651 minus 46651. Let's calculate and see if we get the same answer we got before. So we have 002 multiplied by 18.4578, then we subtract from it the beta m, 6651. What I got here is 17.99498.156. It should be very similar to that one. If it's little bit of difference, it's because of the rounding up. So here 179953. 179953. Yeah, oh, more or less it's the same. More or less is the same, right? More or less it's the same, right? 995. You know, if you round it to 3, if you round it to 3 digits, it will be okay. Yeah, the little difference is because of the discrepancies. The little discrepancies is simply because of rounding up, right? But always worth it to double check, make sure that you got 46651 Yeah, that's very good. And this one 1845, I use the same 1845774, right? Very good, right? So this is very good. Let's look at another concept here, or maybe take another concept. What if you are asked to use life table, find 10 deferred A and 40. Let's complicate it a little bit. This one is easy. Let's add another 4 to it, right? So again, we have A40, but deferred for 10 years and it paid quarterly. There are several ways to calculate it. There are several ways. Let's use the easiest way. The easiest way is to recognize that this 10E40 and this A50. 10E40, you go back to the life table. get it here closer to us so we see it. E40, sorry, 10E40. So now we need to look at 10E40. And E10 at 6092. Right? And now we need to take this one now. A50 and 4. Let's use the easiest way here. The easiest way for us to compute this one, remember we say alpha for 4 A50, subtract from it beta for 4. And let's use this easiest way to compute this one. So now we go back to our friend. What's alpha 4? And you alpha 4 now we are here 4 10019 10019 A50. You look at your table. A50, we need to look at A and 5017 0245. Let me make sure here it's easier for me to look at here. 17 0245 minus beta 4. Now we go back to this one, beta 4 is 38272. 38272. Now let's compute this and see what we get here. If you compute this, this will be 16,645, right? Now this one, 16.645, we need to take it, replace this one here, right? So what it tells us, this one, let's take this one down here. Now this one will become .6092, then multiplied by whatever the number here, 16,645. And this will give us 10, right? So it's again like the logic behind it. Once you are faced with the question like this, to write the formula, right, and then see what you have and what's missing, and then you on the side you calculate each one that is missing, all terms, and then you sort it out. So step by step, you don't need to confuse things. It's not really difficult, it's easy, but the only thing, you know, when you copy numbers, you need to be careful. I tend to make mistakes when I copy numbers, so many digits, but you need to keep, if you compute, you make sure that you keep everything in your calculator. Let's take another idea here, another concept. It's nothing new. What if you want to calculate the continuous case 40, but the question is using life tables, and I with I, here I is given 5%, right? Now we want to find again the continuous case for, instead of paying, you know, $1 at the end or at the beginning of the year, or at the M period 1 over M. Here you paid the $1, it's paid continuously over the whole year. There are several ways, right? One way is, which we did it before, is to say this one I40 divided by, instead of D now we divide it by delta, right? We have all the pieces except A40. What's A40? Now using UDD, and this is approximation, A40 we already did it to be I over delta multiplied by A40. Now I over delta, I mean 0.5 divided by ln 105 multiplied by what is our A40. If you go back to the life table, I'll use it from here. A40, which we already, I use the printout. A40, the A capital 40 is, we already found it before, 12106. If you do that, let's do that. 0.5 divided by ln 105, then multiplied by 0.12106. What I got here for this one to be 0.12406,189. I keep everything in my calculator because it helps me not to lose anything in my calculator. Yeah, 12106. Just can I double check again? 0.5 divided by ln 105, and this one multiplied by A40. Sorry, just make sure that I got the correct number. The A40, the A capital, I mean 0.12106. Yeah, that's correct. Now this one, now I need to take this one, plug it in here. So this one will become 1 minus 0.12406,189 divided by ln. Right. So the answer will become, if you keep it in your calculator, you didn't delete it, then it becomes easy for you to calculate it. 17.9532. Right. So this is one way. This is one way to calculate this one. Alternatively, A40, you can calculate alpha, but this is for infinity. A40 minus beta alpha beta infinity minus beta infinity. And now you look at alpha infinity. Now let's look at it slowly. Now for alpha infinity is 1002. Now A40, we go back to the life table, and what is A small letter? This is the annuity for 40, is 18.4578. Now we need to subtract it from it beta infinity, which is this one now, 0.50823. Now let's see if we get the same answer or close to the same answer. So now 1.0002 multiplied by 18.4578, you subtract from it 0.50823. 17.9532615 should be very close. 17953, 17953. Very good, right? Very good. So this is very easy. Now let's take very easy now. It's not much of difficult questions, so it's very easy to use the life table. You can use the term benefit. You can calculate lots of things. I also in the problem set I'll add extra. But now let's look at another concept here: increasing or decreasing, increasing, decreasing life annuity. Nothing new. We use I for increasing, D for decreasing. But let's take one example to easier than, you know, looking at concepts. Let's take one example quickly. I put this one here. This is also from Society of Actuaries. One of the questions was from Societies of Actuaries. Right. So for this question, we need to calculate the net present value for this interesting temporary life annuity, and it's actually increasing temporary life annuity. So it's issued for a person age 20, right? And this 21, 22, 23, 24, maybe we'll keep 25 in case we need it. So this benefit that we are looking at, it pays 13579, but when it pays, it says it's due. Due, it means at the beginning of the year. So this benefit, we are looking at the payment for this benefit is 13579, and it's at the beginning of the year, right? So here 0. So we need to calculate the actuarial present value. So we need to calculate, the question is actuarial present value of this payment. We are given some information here, right? So how we can calculate it when we don't have interest, we don't have mortality? Well, we are given information, we need to make use of it. So this one, it starts at the beginning of the year, right? But it's because we have variety. Actually, there are several ways to do it. But the one here, it's easy because there are 5 terms here. 1, 2, 3, 4, 5. But the one at the beginning of the year, it's easy to add it. You don't need interest. You don't need a probability because it's certain to get this $1. So I would rather start with this one here. Why? Because at the beginning I can add, but it's the 4, it will cover all the way to here, right? This one, it will not cover it here. This one will give you here 0 payment. So you can still do it with that one, but let's use, I would say, the one that covers all the way to the end. I will use now in different color IA and see what it is. Now IA, no, we'll use the one that gives us at the end of the year 2044. Now this is at the end of the year, right? And it's increasing. It starts with 1 and increase. So at the beginning of the year, it doesn't give anything. It gives us here 1, it gives us 2, gives us 3. How many terms? 4. So we need to have 4 terms. 1, 2, 3, 4. Right? But here you see it's different. So maybe we can make little adjustment. Imagine if you multiply this by 2. Then now this one becomes not 1. Become 2. 2 times 2 it becomes 4. 3 times 2 becomes 6. 4 times 2 becomes 8. Right? We're getting there. We're almost there. If we add 1, so we need 1, 1, 1, 1, right? So which one gives us 1, 1, 1, 1? Let's see. We have this one. The problem with this one, it will give us here 0. And this does not help. So let's take also this one here. So now you add it 20 for 4 years, because it gives us the end of the year, so it gives us 1, 1, 1, 1, 4 terms, 1, 2, 3, 4. It gives us $4 paid at different years. Right, we almost there. If you add this, this give you this, give you this, give you this. The only thing here we are missing 1. Simple, this one is easy. Let's add another one. Now let's put everything together. Again, in actuarial math or interest theory, by now you know it's very important to visualize. Most questions you solve them by visualizing them. It's being mechanical, just using formulas sometimes does not help. It's good to know the formulas, but what's more important to be conceptual, visual, right? So now then the actuarial present value of the payment we're looking at, this one, we already said it's equal to 2, let's use the same color here, 2IA20 for 4 years. This is 1. Then we add to it A20 4. Then we need to add one more, $1. So this is a good question. This is the kind of questions I like. They are conceptual, not so much of calculation, but actually very conceptual. It makes sure that you understand the material. So now if you calculate the actuarial present value here is simple. You have to, you're given all the information, IA to 7.17 plus the one that is also the immediate one is 3.04 plus 1. If you add this quickly, I got the answer to be 18.38. The actuarial present value. We finish this chapter. We are done with this chapter. Next time we'll look at the premiums. So now I also posted the new problem set. You should solve all the questions. All right. Take care. I'll see you in the next chapter.